Hey, what's up everybody? Alright, we are switching our focus. We've been working with univariate data, which I'll explain in a moment, and now we're going to switch to bivariate data. And in this first lesson for chapter 10, we're going to be focusing on scatter diagrams. Pretty simple idea, just some concepts that you need to understand in regards to that very simple idea. What you're going to do here is you're going to use scatter diagrams in order to analyze the direction, shape, and strength of the correlation between two variables. All right, you're going to analyze the direction, shape, and strength of the correlation between two variables. Well, let me go ahead and explain a few things to you here. First of all, I mentioned this term univariate analysis or univariate data a moment ago, and I want to compare a univariate analysis to a bivariate analysis really quickly. And the basic thing here is that whenever we were dealing with univariate analysis, we were dealing with one variable. And that variable could have been height. It could have been test scores. It could have been, SAT scores, which I guess are still test scores, right? But the idea is that you're analyzing one variable. And often what we did then was we took that one variable and we looked at the frequency with which certain data values or groups of data values occurred with the intent of answering a couple of questions. One of the things we wanted to know about that variable was what is a typical value for that variable, in which we use the mean, median, and mode for that. And then the other thing that we often are asking then is how much variation is there in the values of that variable. Okay, now with bivariate analysis, we're going to be comparing two variables. And for instance, one of the things that's going to be majorly different is the type of graphs associated with this kind of analysis. We use a lot of frequency and cumulative frequency diagrams to analyze one variable data sets. To analyze two variable data sets, we're going to use scatter diagrams, which is, again, what this video is focusing on. And you're going to notice scatter diagrams compare pairs of values between two variables. Now, those variables, it could be height and weight. It could be hours spent studying and test scores. All right, it could be age and IQ scores, something like that. Okay, we're comparing two different variables, and our focus is a little bit different. We still might care what a typical value is for each of these variables and how much they vary, but what we're really concerned about with bivariate analysis is whether there's a correlation. All right, so is there really a relationship between the price that you sell a product at and the volume of sales or your profit, that kind of thing? Is there a correlation? That's what we want to be able to determine, and how strong is that correlation if it exists? All right, well, you have three things that you're going to be doing to describe correlations in this section. All right. We're going to be looking at scatter plots, and we're going to be describing, first of all, what's called the direction of the correlation between the two variables. Now, the direction of the correlation is basically going to be positive or negative, and it's all going to be about whether the dependent variable, which I labeled as variable 2, increases or decreases as the independent variable 1 increases. All right. Now, here you can see as variable 1's values increase, the value of variable 2 is decreasing, and so this would be a negative correlation. Whereas in the second diagram, as the value of the independent variable is increasing, so too is the value of the dependent variable. They go the same, they both either increase at the same time or they decrease at the same time, and that's going to be a positive correlation then. Great, so you can have a negative correlation or a positive correlation. That refers to the direction of a correlation between two variables. Another thing we care about is the shape of the correlation. All right, and I've drawn a couple of correlations with some shapes that you would be able to see pretty easily. I think if I draw a trend line or a trend curve, can you see in this first scatter diagram that I can draw basically a line and the scatter points tend to follow that line right there? Well, that means that that correlation has a linear shape to it. All right. Whereas if I were to draw kind of try to draw the trend for the second set of data, it wouldn't be a straight line, it would be more of a curve like this, which based on your knowledge of graphs, you know that that could be, for instance, a logarithmic shape. But for what we care about, we just care whether the shape is either linear or nonlinear. So we would say that there's a nonlinear shape to the correlation between these two data values. Okay, so positive or negative, both of these were positive correlations, by the way, linear or nonlinear. All right, and one more thing that you use to describe the shape, or sorry, just to compare two variables in their correlation, is the strength of the correlation. All right, and the strength of the correlation can basically be determined by how closely the scatter points form a specific shape. All right, now do you see how these scatter points almost form a perfect circle? You can tell that it's a circle, right? Or if they formed a perfect line, or if they made together a perfect curve, what you're going to do is you're going to say there's a very strong correlation. Okay, this is an example of a strong correlation between two data values. All right, now right here in the second one, well, there's a decently strong correlation, right? You can definitely tell what the shape of the data set is by looking here, but the points are a little bit more scattered. They're not perfectly forming this exponential curve right there, or actually quadratic curve, probably. And so, well, oh, I put the strong in the wrong place. There's where our strong correlation goes. You'd probably say that this middle data set has a moderate correlation. And this last data set, well, maybe you can imagine that there's a trend going there, but certainly the points don't seem to form any particular shape, and it's at best a weak correlation is what you could say there. All right, so strong, moderate, weak, positive or negative, linear or nonlinear. Those are the things I care about whenever you're describing the correlation between two variables. Now let me give you one example here. Let's say we want to describe the correlation between the height and the weight, and let's say that this is for adult males. And you can see here I've given you a data set of 8 males. There are 8 columns there. And I've given you the height in centimeters and the weight in kilograms of each of those males. Now I've gone ahead and made the scatter diagram with this data set, and you can, if you like, pause the video and try to see how I made that, but I think you know how to graph ordered pairs pretty easily. And I'm telling you to describe the correlation. Well, we're going to consider those 3 things that I mentioned before. First of all, what's the direction of the correlation? Well, it seems pretty clear to me that as height is increasing, generally speaking, weight is increasing as well. So there's a positive correlation. And then shape. Well, you could kind of draw a trend line here, couldn't you? Take a look at this. If maybe this line right there would be the shape of the trend. And you can see I've got about an equal number of points above that trend line and below that trend line. That is the general direction of the trend. And so we could say there's a linear correlation. And then is it strong, moderate, or weak? Well, we'd probably say this is a moderate correlation at best for the data set that we have. Although I think if you actually collected, hundreds and thousands of data values for this, you'd probably find a very strong correlation between height and weight. Okay? But for this data set, we would say this. There is a moderate positive linear correlation between the height and weight of adult males. That's basically what I need you to be doing. One quick note that I want to make here, and this is something that people don't think about all the time, that's all, is that correlation between two data values or between two variables is not the same thing as causation. And let me put this in the context of this problem right here. We could say that it's possible maybe to guess the weight of somebody based on their height because there appears to be a correlation that we could use to relate the two, right? But does that mean that somebody's height causes their weight to be a specific value? Well, there's other things called confounding factors that can cause somebody's weight, such as the amount of hours they spend exercising every week and their caloric intake, right? So we can't say that height causes weight or vice versa, but certainly there is a correlation between the two. All right, that's scatter diagrams. That's what we're trying to accomplish with bivariate analysis. Thanks for watching. I'll see you next time.